Although we have a light audience, we will not stop the show because we're finalizing our third period. So we're going to start off with getting another uniform member up here on the front, letting us know what's going on in his part of the world. So with further ado, Warrant Officer, my apologies. I'll push later. Warrant Officer Evans, please, the floor is yours.
Hey, good afternoon, ladies and gentlemen. I'm Chief Warrant Officer Matt Evans. I'm with MARSOC G6. I'm a Spectrum Officer down there. Accompanying is my Chief, Staff Sergeant Natasha Vovey. Raise your hand, that way everybody can put a face to the name. Basically, what we're going to be talking about today is a GPS denial PME that we ran last year. Some of the things that we did, the audience that we had out to actually conduct the training, it was extremely valuable, a lot of positive feedback, and we're going to keep this thing going. So just wanted to put it on everybody's radar and look out for the new message traffic. So we jump right to the next slide. Okay, so for the agenda, we're just going to go over the background. Hey, why did we decide to do a GPS jamming PME? The attendees that came out for the training and the trainers. We're going to go over a quick neat overview, the equipment that we used. We're going to talk briefly on the radar application. I know Khaki already touched on radar, but we're going to go into it a little more. And then we're going to talk about the equipment tested, and we'll close it out with the way forward, where we're going from here. Okay, so the background, basically the issue is MARSOC, when we were training our communicators, they would not receive actual GPS effects until they are at their deployment certification exercise, and they're expected to know what to do, during showtime. So it was a huge issue because, they're at that final stage of that pre-deployment training cycle, and they have no clue as far as when these effects happen, what it's supposed to look like, how to report it, so on and so forth. So what Sassar and Bo and I did is we started integrating, GPS effects early on. Their TRX-1, that's their first exercise that they do. TRX-2, we built JSRO portals, training portals. So when they actually get hit with these effects, they have an actual training portal to go to get sets and reps for deployment. A lot of positive feedback, but we wanted to take it a step further, right? Even when you're at a TRX-1, TRX-2, these SOC communicators, they still got those nerves running through them. They're still being technically evaluated. So we wanted to take all of that evaluation out of it. Say, hey, bring out your equipment. You're going to get some, expert knowledge from the Space Force, GenWick, so on and so forth, and then we'll go out, we'll turn the buzzer on, and see actual effects in real time. Take notes and hopefully build TTPs from that. Okay, so individuals that came out, obviously MARSOC communicators. We had FMF, some individuals from 2MEF. They're right across the river. They showed up. We had some PNT SMEs from NIWC Atlantic show up, and then a couple of representatives from ICTISA. We broke the PME into 3 days. So day one, we had the 527 Space Aggressor Squadron come out. That's some MARDET that falls under the Space Force. So they provided a brief on GPS mitigation, and they also provided a SATCOM vulnerability brief. And then day two, we had Joint Navigation Warfare provide a brief on GPS mitigation, and we actually went through real case scenarios and the outcomes of those. And then we closed it out with PEO Spectrum, who provided a brief on the new JSRO portal. And we actually opened up real-world GPS events, walked through them, and then talked about the resolution on those events. The equipment we used is just a neat jammer commercial. It's only pushing 10 milliwatts on L1, L2. On the right, this happened on day one. We gave a brief on the actual emitter itself. And then we also talked about the process of getting GPS effects approved and the lengthy process it has to go to from the MARSOC G6, the Navy Marine Corps Spectrum Office, NMSC, and then finally STRATCOM with FAA concurrence. Big shout out to you guys. This wouldn't have been able to happen without you, so much appreciated. Day two, we talked Dagger training, the Defense Advanced GPS Receiver. So we use the Dagger generally for timing in our radios, but there's an awesome feature on there when GPS jamming is in the environment. You could use that for notification one, and you could actually, somewhat DF using that device, body shielding, whatever's in the environment. So we just wanted to show the Marines that there's another tool in your inventory besides Spectrum Guard Pro or, besides looking at your Garmin and you're not pulling a GPS plot. We touched radar application during the Khaki brief. So a little backstory about radar. I know Jerem was saying it started out of MARSOC. Gunnery Sergeant Hone, my prior chief, and I, we went to the Marine Corps software factory and we said, hey, we got a problem here. These SOCs are the busiest communicators in the Marine Corps, and they're also expected to do real-time spectrum analysis, right? So looking at a 2D trace on a spectrum analyzer, looking at exceedance lists, it could get task extensive. So we wanted to come up with an application that resides in TAC, which is our warfighting cop, that puts it all in one single pane of glass. You have your PACE plan, your primary alternate contingency emergency. It's all laid out perfect. It's color-coded. It shows you the specific frequency, the band, and if it's getting exceeded or an anomaly is recognized in the environment, not only is that net going red, but you're also getting an audible tone. And it also does MCON validation. So I know Jerem was talking about baseline comparative sweep, all the same functionality of Spectrum Guard Pro. You're just seeing all the data translated into TAC. MCON violation shows you on the event log, it timestamps it, tells you the frequency. We're trying to get it to a point where you could extract all that information to include the grid coordinate to feed the JSRO site. More to follow on that. But awesome application. The software factory pumped it out within 3 months. So Marines use the software factory and awesome. They're just great. We have a Raider instance up in the back. It's not really part of the brief, but I just wanted to set it up during the break. If you guys want to cycle back there, I can give you a quick demo on Raider. And if you guys want to take it back to your command, I have the hard drive here as well. Okay, obviously due to classification, we can't get into any of the results, but I will talk about some of the parameters we did. Basically, it was bring your own device. When the communicators came out, hey, anything that relies on GPS, bring it out. Open Kubota, do whatever you guys want to do, right? So generally, we had them establish their communication links. We'd go buzzer on. We'd see what happened to the system. We'd go buzzer off. We would see how long it took that system to reacquire. And then we took a step back saying, hey, we're just going to introduce effects in the environment, and then we're going to try and establish link with effects already in the environment and see what the differences are. We also keyed a dagger and had a non-keyed dagger to see the differences there. If you guys are interested in that after action, let me know, and I can provide it to you on the higher classification. Equipment tested is 170 Golf, 163, 167, the Shout Nano. FCDW, every Raider in MARSOC has an FCDW. It ties into the radio network, and then an Iridium sat phone. And we also tested some satellite nodes as well, so our soft deployable node, just think Viasat for SOCOM. Chimeta, the Dagger, which we'd already talked about, multi-mission terminal, and then lastly, we hit the Star Shield. All right, so the way forward, like I said, a lot of positive feedback on this PME that we conducted. We're going to try and do a biannual event. The goal of doing a biannual event is to build an EW package for our communicators going forward, right? When these guys deploy or when they're in the training environment and they see effects or anything like that, I want them to be able to reference something. Hey, I've seen that before. This is what it could mean. What do I do from here? Do I submit the JSRO? Do I go to my 2 to try and get this rogue signal direction found? Just something that they could point to and just build upon, after my time at MARSOC. And that is all I got. Do we have any questions? All right. Thank you. Oh, we got one question.
Hey, good brief there. I just came in just a couple minutes late, but I'm familiar with the Android Tactical on the Army side. How much integration you guys have as far as interoperability? And we're doing some standalone DDL type A TAC, which is called Prism TAC. Mm-hmm. And I'd like to talk to you a little bit more about that and get some feedback from you guys on what you think about it and maybe get you an overview on it as well.
Absolutely. I can link you up with our SOMPI section who deals with all of our TAC form.
Maybe talk offline. Okay.
For sure.
Yeah, sounds good. Thank you.
Right, so I just wanted to see if you can just inform the group of all the GPS testing that you've had, you've been able to perform in Camp Lejeune. Just like how often, and is it, for example, is it like a standing EW where you have continuous, or you do it like maybe once every 3 months, just so the group can kind of have understanding?
So it's case by case. Every event needs to be submitted and follow that process. It's a hefty timeline, 100 days out. For us, I know Gutty Black was talking about 38, but we got to go to Genwick, we got to get the modeling done, so on and so forth. Staff Sergeant Vo actually just graduated from Giant not too long ago, so we could do our own in-house modeling. So that took some of that time off the buffer room. But to answer your question, Mario, every GPS event has to be submitted, has to be approved for that specific event, unlike some of the RF stuff that we do. That answer your question? Lastly, before I get off the podium, I want to extend this invite. We kind of kept it in-house with MARSOC, this first iteration, but with the positive feedback, I want to send it out to the Don, get you guys to come out, bring some of the equipment that you guys want to test, and then just help us build that, that EW awareness package. So, all right. Thank you.
Well, leave it to the Marines to come in and out, deliver some information that is very relevant down at a tactical level that is applicable to everybody in uniforms and those of us. So really appreciate it. Keeping the conversation moving, Nightway Pack, Mr. Tom Mager, he's going to go ahead and facilitate a discussion regarding future satellite spectrum. So I know that some 7, 8 gigahertz and some other priorities have kept him pretty busy. So please have all your questions ready and pull all that additional information. So.
Hey, good afternoon. All right, we're going to talk a little bit about satellite spectrum, and not just from the federal side, but also from the commercial side. If you've been keeping up with what's going on with the satellites in recent times, we're shifting a lot over to commercial satellites now. WGS is not the beast that it once was, even though it still has its use cases, but a lot of transition to Starlink and other LEO-type satellites. Real quick, for anyone that's, if you're satellite savvy, this is not meant to insult your intelligence, but if you're not, this just kind of gives an overview of the different types of things associated with orbits, and this comes into play for the new satellites that are coming online, especially in LEO, and why this is important to the spectrum community. Again, the apogee perigee, how close or far the satellite is away, how circular the orbit is eccentricity, footprint, big one. Obviously, GEO has a larger footprint than LEO and MEO, and then of course the inclination of the satellite. And the altitude, the height above the object above the average surface of the Earth's ocean, and then this brings the orbits that we're familiar with: LEO, MEO, HEO, and GEO. So HEO orbits, Norway is launching a HEO satellite, and we are using that in cooperation with them. HEO, one of the advantages of HEO is it provides a greater amount of coverage, and it requires a lesser amount of satellites to fully cover the Earth. That Norwegian satellite is a good example. Sirius satellite radio is also a good example of satellites in HEO orbit. GEO, this is the one we're probably most familiar with. It's a geostationary orbit around the equator, so the satellite's always at the same point in the sky relative to the Earth. It has consistently been used for communications since satellites were first around. It's not much used for other purposes, at least not on the DoD side, but GEO, a lot of people say, GEO's going away a dinosaur. I don't think that's true. Orbit diversity is a big thing, along with frequency diversity and others, so I don't think GEO will go away anytime soon, but with the advent of Starlink and others, GEO has kind of taken a backseat a little bit. MEO, if you're familiar with O3b or mPOWER, they are in a MEO orbit. Kind of separates the advantages of GEO and LEO. It's a good trade-off. Of course, obviously the higher up, more latency, so low latency applications like the lower orbits. There are more complexity to terminals though, because we have to have tracking antennas when we're doing LEO and MEO, where we don't with GEO. Then of course, this is the one you're probably most familiar with. Starlink is in LEO orbit. Amazon is also going to be bringing their satellites into LEO orbit in the next few years. And this is one of the primary drivers for the Navy today is if you're familiar with the Sting program, that they're bringing Starlink terminals onto ships and shore sites. And that's, if you were on CVN 72 the other day, you probably heard the multitude of terminals that were on board that ship. Everyone else is thrilled. Dahlgren less than thrilled with that, but it's bringing a lot of capability to the fleet that we didn't previously have. One Starlink terminal that we pay $5,000 for exceeds the amount that an entire carrier strike group used to get just 5 years ago. Satellite positioning, so ordinarily, again, they just stack them up. This is ITU. All your satellite launches get filed with the ITU. They provide you an orbit, a spot up in the sky. They're typically every 70 kilometers is where they park another satellite. And those satellite owners sometimes put more than one satellite in that orbital slot, so if they lose a satellite, they have a spare on orbit. They'll just move it down to the orbit. And this is where most of our communication satellites have been sitting for forever. So the problem from a spectrum point of view is adjacent satellite interference. So the ITU has certain criteria for all satellite terminals that, you know, the beam width, the power in the beam has to be centered within the center of the beam, and that's to avoid situations like this with adjacent satellite interference. It was a lot easier back when everything was geostationary, as long as they kept the satellites separated and they used, you know, frequency management on the satellites. ASI was not as big of a problem in the past. So the problem we have now, we've always had LEO satellites. They were usually for other things like surveillance and things like that. Starlink is really the first one that brought LEO for communications, and they are bringing a lot of them. So the problem is the GEO and NGSO bands are separated currently, but as those satellites go up, as more satellites are coming up, they're running out of spectrum. So they're going back now and saying, hey, you guys aren't using the GEO spectrum like you used to. You should let us use some of your spectrum. And this is the problem you're going to run into, because I'm pointing at that farther away GEO satellite, and those NGSOs are flying right past my beam. So avoiding interference from NGSOs to GSOs is going to be a challenge in the future, especially as these satellites roll out. And then, of course, you have NGSO to NGSO. Even though they're all LEO orbit, they're stacked. That's how they do the separation. They stack them. So if I'm shooting to an Amazon Kuiper satellite, I might be going through a Starlink satellite to get to that Kuiper satellite. And of course, spectrum management from that perspective, as you can imagine, is extremely challenging. They're sharing the same bands. They have to do strict coordination on their frequencies and their particular orbits to ensure that they're not interfering with one another. And so one of the things in the past, you know, if they came after our spectrum, we just went and found other spectrum, right? You take this band, I'll just go find another band. C-band's a good example. We lost the 3700 to 4000. Really had an impact on our CBSP FLV terminals. Essentially, we don't use them anymore. We have very little spectrum left in that band, and I heard the remainder of that is on the block to go. They were seeing interference tens of miles out from shore from 5G that went into the band. So we essentially stopped using that terminal. So in those kind of cases, you know, another, I think a point to remember is we have those terminals built. They're not FCC licensed terminals. So when the spectrum auction came for C-band, we didn't get any money because we weren't using, they give the vendors money to give to their customers to put in filters or whatever they might do to mitigate interference. We didn't get that money because we build our own terminals. So that's just something certainly for the terminal providers to remember, that if they sell or they share that commercial spectrum, you may not get a chunk of that if you're having a vendor build the terminals for you. So you say, why don't we just buy off-the-shelf terminals? Well, we would, but those terminals don't do well in shock and vibration and EMI environments that we have aboard ships. So we generally have to make our own to be able to withstand those conditions. So like I said, we already lost C-band. X-band is the first time they came after an exclusively military band. This is the first time that they've ever proposed. And there's not many left. You know, Tom mentioned UHF this morning. UHF, X-band, KA are really the last military-specific SATCOM bands that we have. And they are now proposing sharing X. And I've seen some proposals, especially on the international stage, not for specifically military KA, but commercial KA. They want to share that part of the band. So we don't have many places to go. Right now we're in XKA and Q-band. You can't go much higher. V&W doesn't do well because of the propagation problems with spectrum up that high. So going to another band is not going to be an option in the future as we continue to share these bands. Sir.
Just based on this slide alone, what we've been describing the entire week is the problem isn't just the federal government, it's industry as well. So it's time to really take a deep look at how do we essentially establish a better method for essentially managing or prioritizing that spectrum. And I think everybody's going to be equally unhappy. It's going to be disruptive, but I think we have to redesign the entire architecture so we look at wide bandwidth as the requirement rather than discrete frequency assignments. And until we do that layered approach, we're not going to get the spectrum we need holistically, whether it's industry or federal government capabilities. I think that environment has to occur, or else we're going to look a lot like this, segmented with really no access.
That's exactly right, Art. So, you know, that's why there's a change of thought to more of a comms as a service. Instead of this is my frequency, this is my part of the band, this is my satellite. Comms as a service says I need access, right? I don't care about the band, I don't care about the orbit, I don't care about any of those things. I just need access. I need to get data from this point to that point. And that's an approach that they're starting to look at. I know being in an acquisition program office for the last 15 years, making changes after that system is fielded, it's $1 million per ship, easy. Any hardware change, it's going to be $1 million per ship because of Navy modernization requirements. You got to go shock it, vibe it, do all the other things to it, the paperwork that goes along with that. So coming back in later and saying, I need to put this filter in, or I need to put this interference excision device in, or whatever it might be, it's very cost prohibitive. They need to be baked in from the beginning when they write the system performance specification. So again, the spectrum, we talked about the alternate spectrum options for satellites are limited, right? They're limited by the allocation for the bands, right? There's not endless bands authorized for satellite operations. And again, moving up is just not an option really. There's a lot of attenuation losses. They could use it in certain situations, but not for the high throughput types of operations and the place we intend to use them. V&W are not built for that. And again, all our satellite communications bands are either being shared with IMT or they will be shared with IMT. You can almost guarantee it. If you're not currently sharing a band with IMT, you will be. And you know, dynamic spectrum sharing is one of the few technical solutions for accommodating the proliferation of NGSO satellites. But again, embedding that, baking that into requirements, baking that into whether it's a KPP or something, has to drive that program office to go chase that capability before they start building that terminal, because after it's too late. The terminals we have today, it would be very difficult to go in and break open those terminals, stick an IES in there or something else. It's very expensive, time consuming, not to mention the RDT&E it's going to take to make that happen. So thinking about things, whatever that might be, whatever we call dynamic spectrum sharing, building that into the terminal is the way to avoid some of the challenges of going back later. Using C-band as an example, it was cost prohibitive to go back and put a filter on those terminals. I think that's all I have. If there's any questions.
So just having a lot of history with satellite, commercial satellite, and managing it for essentially Marine Forces specific at one time. The one item about leveraging commercial spectrum is that foundation of how do we maintain the bandwidth to support the overall requirements. And I could probably go back and talk about the MARSOC days and deck mounting it on the US Ponce and what it cost us to do that. How do we maintain the capability in ensuring that when we provide bandwidth support, that it doesn't run out in the first month.
Yeah, that's, so the challenge is with our, I talked about how much more capability Starlink brings than previous fleet terminals. The challenge isn't with the terminal. The terminal can do 200 megabits per second. The challenge is the service, the cost. One, I won't say the provider, but one beam that we purchased to use was $5.2 million a year. It was one beam for one location. 100 meg up, 100 meg down, it was $5.2 million a year. Starlink for unlimited service is $300,000 a terminal, and the terminal is around $7,000. We wouldn't even bother fixing it. We would throw it away and get a new terminal. That's the game changer that Starlink has brought to. So there's no getting away from commercial SATCOM, and we're going to have to adjust to that. The key with service contracts is how do I get guaranteed bandwidth, right? I have guaranteed information data rates, and that's usually by vendor. We have found that when we know that somebody's going to be launching something in the future, when we go to them and say, hey, we'd like to talk, and we'd like to see if you could maybe add some of these things in right now when you're developing your capability. And some they do, obviously they're there to sell satellite service, right? So some they do and some they don't. But going to the vendors prior to launch, when they're at the stage they're talking about requirements, that seems to have been very helpful. And they say, yeah, we can bring these capabilities into you. Starlink didn't have some of that because Starlink was a service first, and then the DoD went to them and said, hey, we really like your product, we want to. And so they did some things to accommodate us. But going to that vendor, when we know that they're looking at, for example, Amazon's a great example, going to them in advance and saying, could you do this? Could you add this? And they've accommodated quite a bit of it. So, it has helped talking to them in advance.
Hey, Tom, good to see you. How are
Hey,
you?
how's it going, Rob?
Hey, question about, your conversations or maybe collaboration with Space Force with the new MUOS that they're working on right now. Can you talk to that a little bit, or is there any conversation going on with you guys?
So certainly anything on the MILSAT side, we kind of follow Space Force, right? Space Force says this is what we're going to build. They bring in all the services. The Navy will say, hey, we have these unique requirements for the satellite that you're planning to orbit. And they go to each service and they ask for specific requirements from the services. Some make it in, some don't. But generally our terminals just follow, right? They will say the satellite's going to do this, and then we go, okay, we're gonna now go out and have somebody build us a terminal that does that. The challenge with building your own terminals for commercial is doesn't always work that way, right? Sometimes we find out after the fact, and again, even though we are now putting Starlinks on ships, like we have out on 72, the next iteration of Starlink, which is called Sting Increment 2, is actually going to be vendor built. We've actually gone out to a vendor and said, we want you to build us this. Again, we get our requirements in there. The downside is if for some reason that spectrum would go away, we might be stuck with trying to fix whatever issues come up with that terminal. I don't think Starlink's going anywhere soon. Musk seems like he's got a lot of money, so I don't think that Starlink's going away. But everyone's going to have to share. Even Starlink is going to have to find out. They're going to have to share. They all are, or there's just not enough sky left. When we started the Navy Multiband Terminal Program back in 2008, there were 800 satellites in the sky. They are now filing for, by 2029, there's going to be 59,000 satellites in the sky. So there's not going to be a choice but to share all that spectrum.
Hey, Tom, if I can ask a question from a security perspective, is there any concerns that is known that we're transitioning so much to the commercial side from a protection aspect? Obviously, we're on classified level, but is that known that we're all in Starlink, we're all on Amazon? Is that a concern that you guys are forecasting?
Yes, certainly. The people in the cyber world and the security world, absolutely. That was one of the biggest. I think the need for Starlink and the desire for Starlink, kind of everybody jumped, and then they said, okay, we need to start thinking about these things. And again, that's that conversation with the vendor, right? We have requirement. they're not going to provide Transect to their commercial users, right? That's something we have to go and have a discussion with the vendor about. So yeah, those are the kind of things that we definitely have heard it, and we definitely have had to do things to mitigate those concerns. And again, as Starlink launches satellites so often that they can make those changes, right? Maybe the batch they sent up today doesn't have it, but we heard you, we added this on, and the next batch they launch next month has it. So the turnover of satellites really helps in that arena, right? When we identify a problem, they fix it. Anything else?
Great brief, Tom.
Thanks.
So how do you in your office, how do you in your office coordinate with the resource sponsor who funds you for these items?
Now you're going to get me in trouble.
No, because you get me in trouble because we're in here, right? So that's why I asked.
Yes, so this kind of worked itself in a little bit of a different way. It was kind of a fleet requirement that came to 170, and 170 attacked it, right? They said that the fleet came and said, we need these things, and they went out and got these things. It was kind of a discussion afterwards as to, okay, now we, again, like with cyber, like all these other things, we did it, and then we said, okay, there's things we have to go back and address. That was one of those things, right? Sting coming on the ships, Starlink coming on the ships, I think was a little bit of a surprise to some, but again, they had to go back and do that. I know Catnip is another one, right? The MWR system that was Starlink and the Wi-Fi. It was a great idea. The way it went was, kind of the way it went, but there is certainly, Dahlgren had concerns, and we went back and addressed those concerns, right? Then we started making sure, talk to Dahlgren, get the spaces located, make sure that everybody knows what we're doing. So yeah, there was a little bit. Again, this kind of worked in reverse, but I think there has been an effort to go back and make all those boxes get checked. All good? Before I get any more trouble. All right, thanks.
So thank you very much, Tom. I know that there was those initial slides were definitely a one-on-one on satellite. So there's going to be a lot of interest. Try to make sure we get those things out to you. So, but moving right along. So now we're going to follow through with 5G. So Mr. Andy Lady, I know I'm going to do push-up because I said it wrong, but at a later time. But just keeping up the trend. Commercial, yep, satellite, now 5G. I know that the director has a better speech, but in summary, he says a lot, hey, we want 5G in our bases. At the same time, hey, we need to protect our asset from 5G. So how do we do that? And I think it's going to take a lot of help, both from the operational, from the policy side to make that work. But without further ado.
All right, good afternoon, everyone. I'd like to thank Art and his team for having me speak today. I will do my best to review the state of 5G and 5G projects and pilots across the Navy and the Marine Corps as they are today. Should have time for questions throughout or at the end. And I'd like to say up front, if I miss anything that's going on, let me know. Either shout it out or find me afterwards, because there's a lot happening. We want to make sure we're at least aware of everything. First, just a commercial of where I fit in the organization. We fall under Don Serio, so Ms. Rathbun. Her predecessor chartered the Don 5G IPT about 3 years ago. So we fall under the Chief Technology Office, Justin Finelli. Brian Lopez is our Director of Emerging Technologies, and then we fall under his portfolio. And so I'm the Director of the Don 5G IPT, and then we've got a number of lines of effort you can see at the bottom there. Those are the things that we're trying to engage with across the Navy and Marine Corps. We do tie in at the DoD level. So on the left side of the slide there, you see Ms. Ann Rideout. She's our DON Service Transition Lead. She's also our one-star rep to the 5G cross-functional team. Ann is actually going to be retiring soon, so we're going to be looking to replace someone in that position, but Scott Brinson will be acting until a more permanent replacement is found. So Scott Brinson, we're fortunate to have him. He's from NIMIC LANT, but he's the overall DoD 5G CFT service engagement team lead. So he oversees all the services, but we sort of have a special in with Scott since he's from NIMIC LANT. And then relatively recently, a few months ago, Jason Fox from NIMIC PAC is now the the Navy and Marine Corps rep to the DoD 5G service engagement team. And then I wanted to point out we have action officers, across the Navy and Marine Corps. We try to stay engaged as much as we can. If you want to be added to that list, just let me know, and we'll make sure that you're invited to some of our forums that we have, and I'll cover in a later slide. So just a map showing where there are 5G projects going on. There's more and more yellow pins each year that we brief this, but you can see, there's a lot of interest in what's going out into INDOPACOM. We'll discuss that a little bit, but plenty of projects on the West Coast and now on the East Coast as well. So we'll be touching on each one of these at least briefly. So what really kicked this off was, a lot of investment from DoD through OUSD R&E. So back in 2000, we saw, not 2000, in 2020, we saw a lot of investment from DoD, and some of that came down to Navy and Marine Corps, of course. So where we're at on those efforts now, for INDOPACOM, they have something called CFIRE, Command and Control Future G, INDOPACOM Relocatable Experimentation, CFIRE. That's just an umbrella for everything that they're doing in INDOPACOM. So primarily, we have an effort to extend the networks west of the IDL in support of, INDOPACOM. And so we have those, you can see a picture of the Portable Operation Network Integrators, or PONIs. Initially, OUSD R&E invested in COLTS, cells on light trucks, which you might see the cell phone companies will provide, like in the fires in LA, they send these COLTS up to augment their commercial coverage. INDOPACOM wasn't interested in, moving these large trucks around, so they said, can you put them in just like Pelican cases? So just the equipment, we'll worry about the transport and the power, just give us the equipment. So that's what the PONIs are. OUSD R&E did invest in those, and many of them ended up in INDOPACOM. You can see a photo of them erecting one there in the field. They can get one up and operating in about 30 minutes. It's got a 5G core included, and they'll typically connect to something like Starlink for backhaul, but sort of like a tactical bubble of connectivity. They even did some testing with a field solar panel array so that they were able to operate purely off of solar power in one of their exercises. So that's one of the things they're interested in. NAS Whidbey Island is a very large 5G network. It is an Open RAN network where Hughes is the main network provider there, supported by Federated Wireless and JMA and some others subcontractors. That's still up and running. It's designed to primarily cover the flight line area to support the growlers and the P8s up in Whidbey Island. It's very high performance network, and they're continually finding more and more use cases for it up there. So that continues. Then we've got, there was a network in Hawaii itself on Oahu that was part of the experimentation. That was a Verizon contract that was really using their regular commercial. It wasn't a private network. It was using the commercial 5G network that Verizon provided. They did augment it again for the flight line area in Oahu. That particular effort has really ended at this point. They've gotten what they needed out of that. Some of the use cases transitioned more on the Air Force side, but they're Verizon still obviously has a commercial offering there, but there's not active experimentation going on that particular network. But some of the things that were happening at Lualua, they set up a network there, again, Open RAN, very similar to the Whidbey Island network. Some of those resources are going to be moving out to Tinian and Palau and some of the west of the ideal locations. So that's what they're working on there. And I'll just shout out the NAVAC Code H. They're really the ones on the front lines making this happen, working with the various services out there. This was a joint experimentation, so all the services had some play, although Navy and Marine Corps did. Although Air Force participated quite a bit, Army much less so in Hawaii. So that's CFIRE. Another OUSD-funded pilot was the Smart Warehouse at Marine Corps Logistics Base, Albany in Georgia. So that is considered now one of our successful transitions, and unfortunately one of our few successful transitions. So that has transitioned from OUSD R&E funding to MARCOR LOGCOM funding. So Federated Wireless is providing that network, and they've got a 3-year contract now that they're executing. And MARCOR LOGCOM has expressed interest in getting proposals for perhaps extending that to additional locations. But that network just supports the smart warehouse technologies that were also part of that experimentation. And by the way, that was using primarily CBRS spectrum there in Albany, which worked well given its location. Camp Pendleton, another big OUSD R&E pilot. This was probably the most tactical of the use cases that we've seen so far. This was Expeditionary Advanced Space Operations. They had a private 5G network provided by Lockheed Martin. OSIRIS is what they called it. And one of the things they focused on was connecting to the Gator radar and also some other use cases like a 5G drone and some tactical radio integration. That really culminated in just this last December with the Steel Night exercise at Camp Pendleton. They focused on all these use cases, but they really showed off the Gator radar installation. So the Gator radar, instead of connecting via fiber or some other means, they were able to connect just with the 5G system. They did have to notch out some of the frequencies on the radar in order to make it work, but they were able to make it work. That is wrapping up from an OUSD R&E perspective, but they are transitioning the resources, the hardware, the system to MCTISA, where they intend to continue experimentation as a 5G lab there at MCTISA. And NAVAC is also working with MCTISA to support that. Next is the 5G Smart Warehouse in Coronado. That was very similar use case to what was happening in Albany, but this was obviously Navy focused here in Coronado. That was under AT&T contract to provide the network, and they had various vendors that were providing the smart warehouse applications that were taking advantage of that network. This really wrapped up in FY24. No more funding from OUSD to continue this, and NAVSUP is interested in the applications, but not as interested in the 5G network. They're going to try and continue the connectivity using Wi-Fi alone. So that equipment is going to be warehoused and available for other uses if we can find them. I should mention the Macon Island, USS Macon Island had some ship visits set up this week. They're hoping to be able to leverage some of that technology on the Macon Island to continue some of that supply smart warehousing technology afloat. Then we had Naval Station Norfolk, which was, I think, the last of the big OUSD R&E funded 5G exercises. This was intended to be installed on an aircraft carrier. They targeted a couple, but mostly the Bush was the target to have the installations. Unfortunately, the funding wasn't enough to do any of the actual shipboard installs. They did a lot of the design. They have a lab set up at NAS Norfolk, or Naval Station Norfolk, and they even did like ship drawings and things like that, but not enough funding to actually do the installs on the Bush. They did some spectrum analysis, a lot of good work done. They were creative, and they actually, if you can see in the picture there, they ended up doing some testing on the USS Wisconsin museum battleship in Norfolk. and it was actually a fairly good representation within the skin of the ship of how 5G would operate. So they did some testing there. The lab is going to continue to be a resource for NAVIC Atlantic there in Norfolk, and they've also engaged with Military Sea Lift Command, and I'm going to touch that a little bit more in a couple of slides. And I should also mention there was a NATO digital backbone experiment, or DIBAX exercise that was briefed in one of the other rooms today, or yesterday actually. And the same team from Norfolk participated in that, went over to Latvia where they had some afloat 5G experimentation with a Latvia ship and a US ship. So definitely that effort hasn't gone to waste. We're looking forward to seeing what they'll do next. So now the Department of the Navy funded 5G projects. So there are some projects that do have true Navy or Marine Corps funding. And one of those is the Guam Naval Shipyard 5G private cell network. So you're probably aware that we have subs that are going to be based in Guam now, and the shipyard wanted to beef up its ability to track resources, partially in support of that. So this is actually a detachment of the Pearl Harbor Navy shipyard, so they're the ones that are overseeing this. There's a contract with Booz Allen, supported by Federated Wireless, to put this network in place. Installations are well underway. I think they're considered installation complete, doing configurations now. Expect to have an ATO later this year and be fully operational by October, November of this year. And that was definitely something that, the same contractors that we saw at like Whidbey Island and Norfolk, teamed up to provide this network. So we do think that's not a direct transition, but we certainly were able to leverage some of the things that we learned from the OUSD Army pilots. And by the way, they're planning to use CBRS initially. Funding allowing, they have options to do N79 spectrum in the future. So that would be very interesting if they're able to do that. But for now, it's CBRS. Then we have PEO Digital has funded this Guam Mobile Virtual Network Operator project. If you're not familiar with MVNOs, and MNO is like the AT&T, Verizon, they're the mobile network operators, but then you can have companies like Cricket that essentially become virtual network operators. So they pay the AT&Ts and the Verizons to ride their network, usually at less performance, but they don't tell their customers that. But we're able to set up an MVNO in Guam to see if we could share the RAN of the commercial networks that are available there, but still have it routed to a more protected 5G core, what's called a heavy MVNO implementation. So that's up and running now. The Lincoln was able to do some experimentation with this on their last deployment, so they stopped in Guam on the way over. If you're able to see Captain White brief that this morning, it's very interesting what they were able to do. So they were able to connect to the 5G network from the Lincoln pier side, and I think they had 6 different 5G antennas that were connected via SIM bonding to have robust connections to the ship. And then they thought they should see how it worked underway. So they did do some experimentation underway going through the Philippines, and he was reporting some pretty surprising results in terms of range that they were able to have some 5G connectivity. And by the way, some of that started when they were just pierside here in San Diego. They wanted to see if 5G could augment their pierside connectivity. So we helped give them the equipment, cradle point modem, and some 5G devices that would allow them to, just for the ship connectivity, augment their bandwidth here in San Diego, with the idea being that they could perhaps use that in foreign ports where they may not have regular pierside fiber available, and it maybe would be cheaper than maintaining the satellites in port. So that's Guam MVNO. We know that NPS is very active with 5G. They've got an initiative to do workforce development, so they have a lot of training for 5G. And they also have an open testbed for Expeditionary Future G. They have a CRADA with Qualcomm. I believe they have a CRADA with AT&T as well. So they're definitely doing experimentation up at NPS, and that is continuing. A little bit more from NavAir. They have a project called the 5G Flyer. This is a small business initiative, but they've done quite a bit of testing at various exercises, and they've got funding into the next FY. It's really just a mobile 5G base station, so they've got a core and a RAN that's able to provide connectivity. They've got multiples of these that they're experimenting with to provide, again, warfighter connectivity at the edge. And then, as I mentioned a bit before, the Military Sea Lift Command is interested in 5G primarily for additional backhaul or bandwidth off of the ship. Again, that Norfolk team that was initially OSD Arnie funded is now working with MSC ships to provide that connectivity. And Norfolk Land is primarily supporting that effort. And then we've got 29 Palms. Matt Marino briefed that earlier this week. I wasn't able to see it myself. They've always been forward-leaning and trying to get whatever they can to improve the connectivity there, mostly for the people conducting the battle exercises there, so that the trainers can have better connectivity out in the field. And so they were able to take some of the equipment that was originally being used at Fort Irwin under the OUSD Army pilots, and they're trying to implement that at 29 Palms. There's always some funding questions for that, but they're always doing the best that they can. And I actually don't have the latest status there, but I can put you in touch with Matt Marino to get the latest. And then just some other sort of cats and dogs. We've got the more Gator radar spectrum testing that's happening at Cherry Point. Some of the Don Serio spectrum people know a lot more about this than I do, so I'm sure we could hook you up with people to get more information. But we know there are interference issues when you're running the Gator radar with some of our 5G spectrum bands, so trying to get more information about that. We also have a more research project called OCUDU, which is an Open Centralized Unit, Distributed Unit. If you're familiar with Open RAN, that's an initiative that DoD is very interested. All of U.S. government is interested to sort of increase our U.S. industrial base and our competitive footprint in the 5G infrastructure world, so we're not always going to Nokia and kind of some overseas companies like that for our infrastructure. So this is supporting that to provide end-to-end 5G open source software that could be DoD owned to implement that in the Open RAN sort of architecture. So OUSD Arnie is funding that with NAVAC support primarily, although other entities are also involved. And then relatively recently, we found out that Crane, Naval Surface Warfare Center Crane, is going to be standing up some spectrum testing there as well. Initially, that was done at Hill Air Force Base as part of the OUSD Arnie pilots that were kicked off a few years ago. It looks like Crane is going to be continuing that work there. I don't believe it's kicked off yet, or if it has, it's been just in the last week or two. So that's really a recap of the projects. I just wanted to introduce a little bit more, and the previous speaker, Tom, covered a lot of this. But I love this slide. This is from Qualcomm. It just gives a good graphical depiction of all the 5G spectrum internationally. So, the spectrum from left to right is spectrum, and each row is a different country. The white lines are licensed spectrum, and the gray lines are unlicensed or shared spectrum. And of course, most of you are probably aware of this, but they do have to somewhat harmonize these spectrums around the world. You can't just pick whatever frequency you want, even if you have that allocated, because the Qualcomms of the world aren't going to produce the chips unless they can do it at scale. So they need, Europe, Asia, a lot of countries using the same spectrum so that they can make the hardware. And of course, that's what we want to keep in mind. So if we take advantage of some of the spectrum, we want to be able to have the user equipment that is compatible with these frequencies. And what is interesting to us is when, again, you're probably aware, but like N79, we have some DoD allocations in that band. NATO has some allocations within that band. And N79 is a spectrum that's used primarily in Asia. As you can see, like Japan, South Korea, and China have some allocations in some licenses in that range, which means there is user equipment, there are cell phones and other devices that are manufactured at scale that we may be able to take advantage of, even though it's not licensed in our country. And then just to, again, reiterate what Tom was talking about and probably others, the non-terrestrial networking is definitely ramping up very quickly. This is just a snapshot of some of the companies that are getting involved with this. Of course, everyone knows about Starlink, lots of satellites. These numbers, are changing day to day, so don't hold me to it, but they were accurate as of, a few weeks ago. Starlink has partnered with T-Mobile, so they're not always going to be using, the Starlink assigned frequencies. They're going to be leveraging the frequencies that the MNOs have for their direct-to-cell capabilities. So your cell phone may not even realize that it's talking to a satellite because it's using the same frequency that it would use to talk to a cell phone terrestrially. They're initially at least intending for this to light up the dark areas where they don't have good cell coverage today. So you're not going to be connecting to a satellite probably here in San Diego, but if you go out to 29 Palms, maybe you will be in the future. I'll just highlight AST Space Mobile as another company that is really has good funding, and they've got some good partnerships with AT&T and Verizon. So again, they're going to be leveraging AT&T spectrum, Verizon spectrum, at least in the US, when they're connecting their cell phone customers to the AST Space Mobile satellite. And AST actually just made an announcement just yesterday, I think, of the first video telecom, like video phone call with Vodafone in Wales in England through the satellite. So definitely something we're going to be seeing coming online. I should mention that Starlink and the T-Mobile partnership during the hurricane in North Carolina and the recent fires in LA, they got permission to put that service into place a little bit ahead of schedule. FCC allowed it, so they were providing like emergency best effort text messaging from T-Mobile customers up to the Starlink satellite. So it's definitely starting to happen. And Amazon Kuiper is coming on strong. They haven't announced direct to cell yet, but I would be surprised if they don't. And they do have partnerships with Vodafone and Vodacom. That's not for direct to cell yet. That's more backhaul for their cell towers to get connectivity through the satellites. And that's primarily in Europe and Africa right now. This doesn't display too well, I'm seeing in this slide, but of course Starlink has thousands of satellites up. They have plans for many more. OneWeb has, on the order of 600 or 700 satellites. They're at higher altitude, so they don't need as many. You're going to see different companies have different strategies for their constellations. So OneWeb goes all the way up to the poles. They have actually a little bit less coverage around the equator. I'm sure it's still fine. I asked Captain White about that this morning. He said they didn't see a big difference. Starlink initially focused on the lower latitudes, but they now offer coverage all the way up to the poles as well. And as I mentioned, Kuiper is going to be coming on strong, and NAST Mobile. All these companies have big launch plans. So we're going to see a lot of this in the future, and it's going to be using spectrum, at least from our MNOs, mobile network operators. The question is, when we're out at sea or we're in advanced areas, will we be able to work with these companies to get access to these services? And I just wanted to mention some of the outreach that we try to do as a Don 5G IPT. We've got a monthly newsletter that is getting more and more professional each month, so it's got some really good information. So if you're not on the list for that, let me know and we can make sure you get on that distribution. I host a monthly Action Officers meeting where we have a vendor presentation each month, and then we if there's anyone else that is interested in presenting, let me know and we can get you on the agenda. And then I just try to provide updates as I know them from the various projects going on. We've got on Teams a Don 5G community of practice that we're always happy to increase the engagement there. And we've got a dashboard available on Naval Lift that I can hook you up with. And of course, we present at the Don IT East and West symposiums like this. But if anyone wants a 5G presentation or a deep dive on a particular part of 5G, NTN, or anything else, let me know. That's part of our job, and we'll be happy to support that. And I think that's what I wanted to present today, pending any questions you've got. Yes.
More of a comment than a question, and some of the key aspects of, I think we're really at a breaking point if we look at the differences between federal and commercial spectrum. And I realize everybody sees on the news that we're inefficient and ineffective, but the foundation is where 1% of the total spectrum remaining belongs exclusively to the federal government. So that foundation by itself says that sharing is the only option as we go forward. But those key capabilities, as we describe, how do we move this capability forward? Because I look at the Marines, sailors that are in the room, a lot of these capabilities, we had the benefit of using KU in theater, a lot of the things that we haven't seen on our naval vessels at this point. So we have seen those benefits, and we have the best planners in the world. And I think it's time for us to sit down with industry and come up with a solution that looks right for America, not just industry by themselves. So that foundation, until we sit in the same room and design a true architecture to support where we're going, it has to be 3-dimensional and likely 4-dimensional, because the moon is really our next strategy from a national strategy perspective. But we have to consider all our options, terrestrial, aeronautical, and space, and design our architecture to support that always on type capability. If we do it every day, why is our network different from a garrison standpoint, from a deployed standpoint? We talk about data at rest. Spectrum at rest is the same option. If I can design it in a wideband type capability and be provisioned, authorized, all the capabilities that we described are available on demand at that point, and it assists us to do our mission. So we really need to start rethinking how we can leverage this technology, not only from a commercial standpoint, but integrate that type of software into our radio systems. But until we start looking at it fully, we're going to create a lot of mistakes and then try to come back and repair all the mistakes that we made all at once. So let's develop a strategy. Let's work together to get there.
Yeah, totally concur. And I'll just mention that, and to echo what Tom said, I think also these satellite companies are willing to work with us, and it's early enough that we can still influence some of the decisions that they're making, and they're replacing these satellites. They will be replacing them regularly. So we have a foot in the door, and we should take advantage of that engagement and do some experimentation as soon as we can for some of these capabilities. Other questions? Yes?
Yep. Jim Corpine from GIFMO, Alaska. I have a question about all these projects. Do they require the E3 studies from the Joint Spectrum Center? Or are these do they not require that? I know if we have telcos that are doing these projects on installations, we require them. So I'm just curious, for these hosted and sponsored by Navy, do we require them?
We have required them wherever we've done installations. They've had to go through the spectrum studies, HERF, and all that. So yeah, it's been coordinated with the spectrum managers. In some cases, we're using just a regular public cellular technology. But whenever we're doing installations or private networks, yeah, we do have to comply with that. And that is, slows things down, but it's important, obviously.
So that. Thanks. That actually stole my question a little bit, but I'm going to add to it.
The JSC one, they pay for it.
I got you.
Yeah.
All right, so I'm going to build on that just a little bit, and I know we got others waiting to ask questions. So I'm in particular concerned when you go aboard a platform like a ship in terms of the E-cubed assessments. So who is it in general you're working with for those E-cubed assessments for the below deck potential impact?
So they were working with Dahlgren on that, the Norfolk team that was looking at the aircraft carrier installations.
Okay. And my other question is, I'd like to talk with you afterwards. I think Art would like to join for that conversation. I'd like to talk a little bit more about the Crane project, about dynamic spectrum sharing. Thank
Okay.
you.
Great, thank you.
Hey, Andy, do you see competition between the NGSOs and 5G, or are they meant to be an augmentation, or are they competing in each other's space for access?
Between the NGSOs and the terrestrial companies? I mean, we're seeing partnerships so far, but, you know, just like us, the spectrum is a, you know, highly sought after resources. I think they're forced to partner in order to take advantage of the spectrum that they have. And we're seeing that internationally, by the way, just not in the US. But there's still going to be contention, I'm sure, when we're talking about connectivity to ground stations and gateways. They're going to need, you know, bandwidth for that as well. But so far, it's been somewhat cooperative. The FCC did put out a special SCS, satellite communications system, I think they called it. Sorry, supplemental coverage from space, SCS, where they did allow this cooperation between NGSOs and the terrestrial MNOs to share that spectrum. One change that they made was that they did say the satellite had to be provided on a secondary basis, not to interfere with the terrestrial coverage, which was a change from what they had piloted, which was considered a co-primary. So the terrestrial did get a leg up there because their primary satellite is secondary. That's what the FCC did for the US. You know, that's could be different in other countries.
Sir, Chief Warrant Officer Hawk, Marine Forces Pacific. I love innovation. I love taking my phone. I have T-Mobile. I'm using the beta platform, Starlink. I have no gap coverage, all that good stuff. Let's get to the end user device. Let's embrace technology. My question to you, and maybe you're the right person or somebody in this room, Train as you fight, we're doing all this 5G CONUS, which is great. We have a stay through AT&T or through Verizon or whatever, and we have a CRADA, but I'm taking this to the Philippines, I'm taking this to Australia, Japan, Korea, all these other countries. It's owned by the commercial vendor, right? That's their AT&Ts and Verizon. So now we have this deployable node. I'm glad you highlighted some of those units because a lot of those were not approved, and I could not get approval, but still looked like they executed, right? But we couldn't validate it because we don't have sensors. So they still did their 5G testing. But what I'm getting at is how do we get to yes in these other countries without having to lease the spectrum back from the global, like they have global, or one of the cell companies in the Philippines called Global. You have to go lease it. It comes at a very huge price for the government, so pretty much it's unusable when we're going to these countries. Worked with Martha Baez and CENTCOM and that AO back in the day. It was a little bit easier to get approval in CENTCOM. But in the Pacific, it's a different beast. How do we get to yes in these countries and take 5G and use it and change what we're doing? So,
yeah, that's a great question. I wish I had a better answer for you. And I've heard that consistently from the Marines. Chris Wagner has pointed that out, that we can't have something that uses that we can only use in the U.S. Obviously, it's got to be able to deploy. Your options are to work with a local provider. We do have, you know, some military mobile bands that could work. We have to be a little bit careful because what have they been approved for? That's why I sort of mentioned there's some other countries that have licensed spectrum where UEs may be available. Whether we could use that spectrum or not, you know, probably more discussions to be had there. And there's also, you know, even like Wi-Fi frequencies that are somewhat open worldwide, you know, many of our 5G companies consider that to be available to them also. So it's not necessarily always going to be licensed spectrum that you have available. You could look at more open spectrum that have traditionally been used for things like Wi-Fi. Of course, you're still going to have to worry about interference, but it could be a possibility. But Art may have a lot more to say on this.
I do, but let Rob go first, and then I'll close with some of the comments.
Yeah, just wanted to comment a couple of things. Great overview. That's a really good rundown, Andy. I wanted to capture a little bit more on your testing. Are you familiar probably with what they're calling spectrum moonshot, where you have coexistence with 5G and radars? Is part of that testing that you're doing with the Gator considered part of spectrum moonshot, or is that something to be that's being worked on now?
That's a good question. I haven't seen it specifically for at least what's happening in Pendleton. I haven't seen it couched in that framework. What they're doing at Cherry Point, maybe it is, but I'm not sure. Art may know.
Okay. Okay, we can take it offline. The second question, I think that was brought up earlier, is about host nation, agreements to try to get 5G. I was at Army Futures Command, and we did quite a bit of work with John Hopkins to do the Colt over at APG in Maryland. And so I was working with Headquarters Department of the Army back then to do a lot of that 5G experimentation from 2019 and beyond. And so the question I have is how much interoperability and coalition do you have with either Tom Rondeau's Future G and Juan Ramirez, at the DoD CIO CFT to collaborate with the other services? And I know you mentioned Tranche 1 continuation at Hill, where Dr. Ashdown had that first initiative under the Tranche 1, right? So can you comment a little bit and kind of bring that kind of home a little closer?
Yeah, I mean, we definitely worked. I mean, this all fell under OSD ARNI initially. So Dr. Joe Evans was the first person overseeing this. He had someone else, and then Dr. Rondeau. DoD CIO officially took over cognizance of the 5G pilots. OUSD ARNI maintained the Future G experimentation. So there's still definitely coordination to be had there. We work closely with them. Our Indo-PACOM team in particular works very closely with them. And as I mentioned, we've got Jason Fox, who's our rep to the 5G CFT. So we are communicating at the DoD level. I would still say we're still not great at the Navy to Army, Navy to Air Force direct. But I think we have room to get better. At the CFT level, they're doing more at that. I'm not seeing as much on our end, but I think we should do room for improvement there. So acknowledged.
So let's address the whole context of host nation coordination and all its components, because some of the key criteria when we look at how do we plan from a Department of Defense standpoint, we've spent many years harmonizing our spectrum across not only the United States, but with our allies. And some of those key aspects of every time that we go through a spectrum auction, it breaks some of those requests and some of those long-term capabilities that we built with our allies. So that foundation of your question is how do we leverage that capability? Well, we harmonized those bands already. It's more how do we build that interface into our current radio systems. And I realize cost becomes a huge thing, because 90% of our conversations is show me the money throughout this week, training, all those components. But that's the basic foundation. Start small, make mistakes small. Then when we work out the details, get our lessons learned, then we start to build onto those specific requirements. But we have to start looking at those military bands. And when we talk 5G as a technology, I see it as a IEEE standard. It's a software, it's a capability that can be integrated into any device that we have within the military. You look at some of the things that we were talking about yesterday, geeks tracks, and how do we ensure that we have the ability on our naval vessels to essentially sense and avoid our spectrum usage so we're not interfering with ourselves. That's a software component that's built into cellular providers' capabilities. There's some benefits that we could take from this, but we need you young kids to really get into it and look at how do we make the best bang for our buck, because we can't afford to pay commercial leases forever. I've seen those cost. Just the one time that we've, in MARSOC, in its earliest days, deck mounted it on the US Ponce. We're doing blue mail back then. What it really costs is $1.2 million a week. Across the force, we can't afford to do that at a large scale. So we have to be mindful, how do we do this realistically without creating a huge cost? So those are the hard capabilities, but until we sit down as an organization and really build on that and create a strategy, and I still believe that strategy is in here, because we can design an architecture that benefits not only America, and I want to be there first. I want to have that strategy first so we could tell the other countries how to do it. So that foundation is us in this room that make that happen. That strategy is not going to get there without us. I know that that foundation of how do we plan to deploy in harm's way, no one in the world can plan it like us. So I know that it's going to take us getting in the room to start looking at those type of requirements, and that's really the challenge for all of us. How do we get industry in the room and start to talk about that Apollo mission for Spectrum, because it is a finite resource. The key piece I've always looked at is those 4 dimensions of communication, and if we're really going to do a Spectrum on demand type capability, it's going to really look at how do we eliminate the allocation table holistically in the service rules, because the technology can do it today. We're the only ones holding it back. And the culture has to change.
All right, well, I think I'm over time, so thank you very much. I appreciate the time.